Alright, welcome back. This is part 2 of section 1-6, which is over midpoints and distance formulas. This part we're going to be talking about is the distance formula part. So the distance formula is given the distance between any 2 points. It can be used to find the length of the line segment. So distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And I think we have an example that we're supposed to find the length AB that has those 2 coordinates there. So I'm going to drag this out of the way real quick. And I'm going to go ahead and start this problem by labeling my x1 and x2. So my first point is A again, so I'm going to call that x sub 1, and then y sub 1 will be the 1. And now my B will be my point 2, so I'm going to label it x sub 2 and y sub 2. I strongly suggest that you go ahead and label, and that way it's just a matter of plugging it in correctly to your formula. So we're going to have the distance is equal to the square root. Well, my x sub 2 is the 5. All I have to do is locate x sub 2 and look to see what is underneath of it. Minus is part of the formula. Don't forget to write your minus even if you have negative coordinates for either one of your points. So now I locate x sub 1, so I've written it down, it's right below it, which is 3 squared plus, now I need to find my y sub 2, so I come down to the formula, here's my y sub 2, underneath of it is 4, minus is part of the formula, and then I'm looking for my y sub 1, so right here's my y sub 1, I've got it labeled, it's the 1, and that should be squared there. So now it's just a matter of, can I simplify this correctly? Now a lot of people try and run and grab the calculator at this point. I don't really suggest that because you've got to put it in just the right parentheses if you're going to try and plug that whole thing out. So all we've got is 5 minus 3, which is 2. I'm going to leave that squared. Plus, I've got 4 minus 1, which is 3. That's going to be squared. So this will be 4 plus 9, which is going to turn out to be the square root of 13. And depending on how the question is asked during the homework, you might have to plug that into a calculator to get it to the nearest tenth or hundredth or thousandth. Otherwise, they might ask you just to leave it as a simplified square root, which would be your square root of 13. Alright, we're going to jump past the questions again this time because they will be in your worksheet underneath the student portal, a little plus sign that you click on. If you're following along on the lesson, I've just got the midpoint formula and distance formula printed off on this page here. Just kind of shows it a little bit differently. And now let's start talking about the Pythagorean theorem. Well, in order to understand the Pythagorean theorem, we must understand the parts of a right triangle first. So the sides have special names in a right triangle, and we have 2 things that are called the legs, which are the sides that form the right angle. So you might remember there should be a little red box or a little box in the corner to signify that it's a right angle. So the 2 that are adjacent or create that right angle, those are going to be your legs. The one straight across has a special name called the hypotenuse, and it's always the longest side in a right triangle. Well, the Pythagorean theorem tells us if we take the sum of the 2 legs squared and add them together, that's going to equal the hypotenuse squared. So you've probably seen a squared plus b squared equals c squared before. Now we're going to look at it along with a distance formula problem. So I'm going to go ahead and plot point D, which is at 3, 4. So I'm going to come down here, 1, 2, 3, up 1, 2, 3, 4. I'm going to put that there and call it D. Now I'm supposed to be finding to the nearest tenth, it looks like, the length of segment DE. So I'm going to come over here and plot E now, so it's to the left 2 and down 1, 2, 3, 4, 5. This is point E down here. Well, we just talked about how to do it with the distance formula, so I'm going to go ahead and copy the distance formula right down here. And I'm going to go ahead and label my points in the problem, my x1, y1, and my x2, y2. So now all I have to do is plug it into the formula. So I'll have my x2, which is -2, minus my x1, which will be 3, squared, plus I locate my y sub 2, which is -5, minus my y sub 1, which is 4, squared. And now it's just a matter of simplifying this. I'm going to put the square root. Well, -3 or -2 minus 3 will give me a -5. And then over here, if I simplify inside the parentheses, it'll be a -9. So -5 times -5 is 25, and 9 times 9, or -9 times -9, is going to give you a positive 81. So by the distance formula, when I add those together, I'll have the square root of 106. Now it's wanting us to plug this out in our calculator real quick so that we can get to the nearest tenth, which is 1 decimal point. So if you have a calculator handy, which any computer should have a little calculator that you can use, you'll take the square root must have to hit the number first in this one. So let's clear that. Let's go 106 and then hit our square root. And it looks like if we go to 1 decimal place, that's going to be 10.3. Okay, let's talk about how we could do the same problem using the Pythagorean theorem. So I'm going to erase this work, and again, if you need to pause, rewind, look at it again, feel free to do so. And I'm going to go ahead and draw that segment now in between these two. And now I want to think about how I could possibly create a right triangle so that I could plug it into the Pythagorean theorem. So I'm going to start with my lower point. I'm going to come straight over to the right until I get right below that point D, like so. And now I'm going to go ahead and draw this segment that goes straight down until it reaches that point, or that line that I just drew from point E. So now notice that I should have a right triangle there on my grid. Well, all I'm going to do is I'm going to, let's call this point C. I'm going to count from point C up to D. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to put a 9 right there. Now I'm going to count over from E to C. So I'm going to go over 1, 2, 3, 4, and 5. Well, I'm looking for the length of DE. So I've got it set up in a right triangle, so I can use Pythagorean theorem. So these are my two legs here. Here's my right angle, so that's my C that I'm missing straight across from the right angle. So I'm going to put 5 squared plus 9 squared equals C squared. So 5 squared is 25, plus 81 when I square 9 equals c squared. So again, I'll have 106 is equal to c squared, and now to undo the squared, I got to take the square root. So I'll have c is equal to the square root of 106, which we just found out was 10.3 a second ago on our calculator. So that's how we could do the same problem using the Pythagorean theorem instead of the distance formula. And it would work for every single problem. Some of them might be a little harder than others though. Alright, again, we're not going to do these problems. Your problems are already put in under your student portal, so make sure you do the problems there. You should be able to submit them until you get them right. So take your time, do them right. And if you got any boxes today, go ahead and picture that box. And good luck. All right, this is it.